शुरू करते हैं आज की क्लास। सेकंड यूनिट स्टार्ट करेंगे एम्बेडेड सिस्टम की। यूनिट 2 में बेसिकली जो बात करनी है हमें प्रोसेस जो एम्बेडेड सिस्टम में यूज होते हैं लेकर के है, कौन से प्रोटोकॉल यूज होते हैं, इस तरह के लॉजिक यूज होती है, डिफरेंट इलेक्ट्रॉनिक कंपोनेंट्स के बीच में जब कम्युनिकेशन हो रहा हो तो कौन से लैंग्वेज में होगा, कौन सी टेक्नोलॉजी यूज होगी, कौन से रूल्स यूज होंगे, कौन से प्रोटोकॉल्स यूज होंगे, कम्युनिकेशन का मेथड क्या होगा और एम्बेडेड सिस्टम में इनका यूज कैसे करते हैं। बेसिकली हम लोग इस पे बात कर रहे हैं। In this particular unit, we will discuss the basics of the most common protocols such as RS-222, RS-422, RS-485, SPI, I2C, and CAN, mostly used in automobile sector. So this is the major concern area of this unit. Now, when we talk about the different protocols, then SPI, I2C, and UART are quite a bit slower than protocols like USB, Ethernet, Bluetooth, and Wi-Fi. Means these protocols are not much faster like USB, Ethernet, and Bluetooth, but they are very simpler to use and they require less amount of hardware and system resources. So, if you say that we are going to design an embedded system and there is a need of only communication rather to fast it the process, the only need is to communicate between the component. If it is our prime concern, then we use SPI, I2C, and UART. If the prime need is speed, the speed of communication, then certainly we go through USB, Ethernet, or Bluetooth. SPI, I2C, and UART are ideal for communication between microcontrollers and between microcontrollers and sensors. So basically, if we are talking about the communication here, we mean that the communication between microcontroller to microcontroller or between microcontroller and sensor. Why there is a necessity of communicating between microcontroller and sensor? Because the sensors are the device which sends the data. And after sensing the data is sent to the microcontrollers. So actually the data which comes from sensor needs not to be on very high speed. It only needs that the complete data is transferred from sensor to the microcontroller. The two basic type of communication which is used here is number one is parallel and number two is serial. In serial communication, again there is two subdivision, asynchronous and synchronous data transmission. So we start with first serial communication or rather parallel communication. Parallel communication. In parallel communication, all the bits of data are transmitted simultaneously on separate communication line. Means all the data bits are transmitted simultaneously, not one after another. This communication process is basically used for shorter duration. If we are going to transmit n number of bits, then we need n number of wires or lines. Parallel communication. As the number of lines and number of wires increase in this communication, so naturally the cost is also higher in comparison to serial communication. As all the bits are transferred simultaneously, naturally it is a faster communication comparison to serial communication, and data can be transmitted in less time, which is not in the case of serial communication. Examples of parallel communications are printers and hard disks. Printers and hard disks are the examples of parallel communication. In case of serial communication, in serial communication, the data bits are transmitted serially one by one. Means a single wire is used and the data is transmitted one after another. Complete data is not transmitted at the same time. It requires only one communication line rather than n number of lines to transmit data from sender to receiver. So the data is transmitted by one line. So if you have to transmit n number of bits, then you have to transmit it by one bit after another until the n bits are transmitted on that only line. All the bits are transmitted on single lines in serial fashion. It is less costly because a single line or single wire is used, and it is very good for long distance communication. Examples are telephone. So this is the a simple block diagram of serial transfer and parallel transfer. In case of serial transfer, we see that between the sender and receiver, there is a single line. Whereas in parallel transfer, if you see, there are more than one line used between sender and receiver, and all the data is transmitted at the same time between sender and receiver. Serial communication is of two types, or are two methods are used in serial communication. Number one is asynchronous, and number two is synchronous. Asynchronous means transfer single byte at a time. Means while transmitting the data from one place to other or from one device to another device, there is no requirement of clock signal. Means there is no uh, such provision to synchronize the data, and single byte is transferred at a time. Such system is used in UART, that is Universal Asynchronous Receiver Transmitter. The other one is synchronous. In synchronous transmission, transfers a block of data or character at a time. Means transfers a complete block of data at a time, and this data transmission is synchronized by clock. Example of such transmission, such communication is SPI and I2C. SPI means serial peripheral interface, whereas I2C is integrated circuits. So, what is data transmission? As the basic of communication is the transmission, and basically, if we are communicating, then certainly we are transmitting some data. So, what is data transmission? In data transmission, if the data can be transmitted and received, it is a duplex transmission. Means data is transmitted, and not only it is transmitted, but it is received at the receiver end. So, it is called as a duplex transmission. So what is simplex? Data is transmitted in only one direction, that is from transmission to receiver, or only one from transmitter and one receiver. Means here only one transmitter and receiver is needed, and data is either transmitted from the transmitter to receiver. So data transmission is in one direction only. Data is not transmitted back. In a half duplex, data is transmitted in two directions, but only one way at a time. Here, two transmitters and two receivers, and one line is needed. Between two transmitters and two receivers, one transmitter and one receiver is working at the same time. Means both the transmitter and both receivers are not working simultaneously. One set of transmitter and receiver is allowed to transmit or receive. So this is half duplex system. Whereas in full duplex system, both ways data transmission is possible. Means two transmitter, two receivers, and two lines are used. So the data transmission and receiver receiving is possible in both the direction at the same time. So this is the full duplex system. Here you can see that all these three system is used, and graphically, diagrammatically, it is shown here that in simplex mode there is a single line, and the arrow shows the transmitter is transmitting data from transmitting end to the receiving end. There is an half duplex. One transmitter and one receiver can work at the same time. Not both the receivers are working at the same time, or both the receivers and transmitters are working at the same time. Only one is allowed to work. That is one transmitter and one receiver. Whereas in full duplex mode, transmitter and receiver, both the transmitter and receivers can work at the same time. Means transmission and reception can be done at the same time. So both way communication can be possible. So what is protocol? What do you mean by protocol? प्रोटोकॉल क्या है? प्रोटोकॉल से आप क्या समझते हैं? तो प्रोटोकॉल वो नियम कानून है जो किसी भी कार्य को करने के लिए जरूरी है, और ये किसी कमिटी या किसी ऑर्गेनाइजेशन के द्वारा उस कार्य को करने के लिए बनाए गए वो जरूरी नियम कानून है जो सभी को पालन करना है। यहाँ पे कम्युनिकेशन के फील्ड में प्रोटोकॉल का क्या रोल? प्रोटोकॉल आर द सेट ऑफ रूल्स agreed by both the transmitter and the receiver. Means the transmitter and the receiver both have to follow the rules or laws made by the concerned authorities. So here, on what factors does these rules are applicable, or what are the different factors that are kept in mind while discussing the different rules and regulations, that is protocols, when it is in the building process. So first is the how the data is packed. Data pack कैसे होगा? The data is packed in either byte or nibble or double byte of word or double word, and so as they are sent. How many bits constitute a character? So there should be a rule. It shows that how many bits constitute a character. Means a character can be built on using number of bits, and that number of bits are decided before the transmission, and that comes under protocol. Third one is the when the data begins and when it ends. So both the transmitter and receiver should know that when the data is transmitted and when it is received, so both are agreed and both are ready to either transmit or receive at the same time. There should be a time limit. So these are the basic factors on which a protocol is made. Now there is a term known as baud rate. Basically, baud rate is the data transfer rate in serial communication. Means how many bits per second is transmitted through the transmitter, or how many bits per second is received through the receiver. It shows their transmitting capability or receiving capability. Much the baud rate, much fast the data transmission. So the serial communication is measured in terms of bits per second, which is nothing but baud rate. So baud rate and BPS can be used interchangeably with respect to UART. Either we use baud rate or bits per second. Suppose there are 10 pages of text can be transferred, and in each page there is 100 by 25 such characters with the character length is of 8 bits, and it has also a one start and one stop bit. So for each character there are total number of bits are 10. The total number of bits is 100 into 25 cross 10, that is 2500 bits per page. For 10 pages of data, it is required to transmit 250,000 characters. So if the baud rate which is used here for SCI transmission, as we know, in the range of 1200, 2400, 4800, 9600, and 19,200 zone, and here we are going to use the baud rate of 9600. So we can easily calculate the time required to transmit the data. That is 2,50,000 divided by 9600, which is equal to 26.04 seconds, or you can say 27 seconds. So by this way, you can calculate how much time needed when a particular baud rate is used to transmit a calculated length of data while designing an embedded system. So baud rate plays a very important role. Next is synchronous and asynchronous interfaces. So in this unit, we are going to discuss in detail about UARTs, SPI, I2C, and USB protocols. Serial communication protocols can be categorized as synchronous and asynchronous protocols. Synchronous protocols are those protocols which are based on the clock pulses, whereas asynchronous protocols won't need any clock signals. In synchronous communication data, the transmission is received or transmitted continuously at a constant rate, and synchronous communication requires the clock of transmitting device and receiving device synchronized. Means while communicating from transmitter to receiver, there should be a provision to synchronize it. And what we use as a synchronization mechanism? Clock. So clock is used here for synchronization purpose. In most of the systems like ADC, audio ports, potentiometers, transmission and reception of data occurs with same frequency. Means if we are using ADC in our embedded system, audio ports, potentiometers, transmission and reception of different data from different channels, then they all have the same frequency. An example of such synchronous communication are I2C and SPI. In the case of asynchronous communication, the transmission of data requires no clock signal, and data transfer occurs intermittently rather than steady state. Means in asynchronous communication, there is no need of clock signals. and data can be transferred at any time. It cannot have the same speed throughout the transmission. It can only see that the receiver is ready or not. If the receiver is ready, it can transmit the data. Handshake signals between the transmitter and receiver are important in asynchronous communication. So, what is the method to check whether the receiver is ready or not? For that purpose, they need a signal which is known as a handshake signal. Examples of asynchronous communication are universal asynchronous receiver transmitter, that is UART, and CAN bus protocol. So these are the different mechanisms which is used in synchronous and asynchronous communication. And based on these mechanisms, different protocols are made. Synchronous and asynchronous communication protocols are well-defined standards and can be implemented in either hardware or in the early days of embedded system. Software implementation of I2C and SPI was common as well as a tedious work and is used to take long programs. Means in when we are designing the protocol at the early stages, there was certain problem and we have to look over it, solve over it, and it is a very tedious job. Gradually, as the controllers are evolutionized, processors are evolutionized, machines are now modernized, microcontrollers started incorporating the standard communication protocols. So as the hardware part is well developed now, similarly the protocols are also developed in the due course of time. This development in early 90s made job of the embedded software development easy for communication protocols. In 1990s, the development of embedded software is not that much of an easy task. Perhaps which is now, it is a very easy task to develop a protocol. When we look back, we see that how tedious it is before 1990s. Microcontroller of our interest supports UART, CAN, SPI, I2C, and USB protocols. So mainly we are using either microcontrollers such as 8051 or Arduino, Atmel, Motorola microcontrollers. So all these microcontrollers uses these 4 or 5 protocols, that is UART, PAN, that is controller area network, SPI, I2C, and USB. So in most of the modern day microcontrollers, they have this facility to use these protocols. So before studying the implementation and programming details of these protocols in microcontrollers, it is required to understand basic standards, features, and applications. So before going to in detail about these protocols, which is used in microcontroller, we have to know the basics of standards which are used in this, the features which are used in this, and the application area of these protocols. So in the following section, we are going to discuss about the fundamentals of above mentioned communication protocols. So first of all, we are going to discuss about the SPI communication. So what is SPI? And what are its features, general features, what are its characteristics, how it is different from other protocols, why it is used, So SPI is a common communication protocol used by many different devices. For example, SD card modules, RFID card reader modules, and 2.4 gigahertz wireless transmitter receiver all use SPI to communicate with microcontrollers. So when we are communicating with SD card modules, RFID card reader modules, 2.4 gigahertz wireless transmitter receivers, all uses SPI to communicate with. One unique benefit of SPI is the fact that data can be transferred without interruption. One unique benefit of SPI is the fact that data can be transferred without interruption. Means when we are using SPI protocol, the data is transferred without interruption. Any number of bits can be sent or received in a continuous stream. When we are talking about the I2C and UART, it sends or receives the data in form of packets. Means limited number of bits can be sent or received at the same time, and that has to be accompanied with the bits like start and stop that shows the beginning and starting of each packet. Means the data is interrupted during transmission. It is not in continuous form. You have to send an start bit to initialize the operation. Then you have to send the stop condition as stop bit to terminate the transmission progress or transmission process. Devices communicating via SPI are in master-slave relationship. So when we use SPI, then the transmitting device works as master and the receiving device works as slave. Here the master is a controlling device. Usually it is a microcontroller, while the slave usually is a sensor, display or a memory chip, which takes instruction from the master. The simplest configuration of SPI is a single master, single slave system. So when we are talking about the simplest of SPI, it can only have one master and one slave system. But in practical, one master can control more than one slave. So in SPI, there is a provision that it has one master and several of the slaves. So this is the normal SPI block diagram. It has 4 wires between master and slave. Number 1 is MOSI. Number 2 is MISO. Number 3 is SCLK. And number 4 is chip selection. So we are going to discuss in detail about all these things. What is MOSI? What is MISO? What is the purpose of clock signal? What is the purpose of CS signal here? And why these arrows are directioned in a particular way. So MOSI is nothing but master output slave input line. So this line is used for transmitting the data from master to send the data to the slave. Whereas MISO is used as the line to send data from slave to the master end. Clock is used to synchronize it. Without the use of clock signal, no transmission is possible here. Slave select and chip select signals are used for the master to select which slave it wants to send the data. So these are the 4 lines which is used in SPI. In practice, the number of slaves is limited by the load capacitance of the system. Means the load capacitance of the system decide how many number of slaves a particular master should have, which reduces the ability of master to accurately switch between voltages. So ability of master to switch between voltage level is decided on the load capacitance. Number of wires used here are 4 and the maximum achievable speed in SPI is up to 10 Mbps. As the clock is used here, so it is a synchronous transmission process. Data is transmitted serially and the maximum masters, number of masters is equal to 1 and the maximum number of slab is used here. It's theoretically unlimited, although we are using only one slab here. And in further process, we see that we are going to use 4 number of or 3 number of slaves with a single master. And how it works, we are going to discuss in our next lecture. This is all for today. Stop here.